Okay, so we're faced with another problem here, x to the fourth minus 5x squared plus 3 over 8x to the third. If this problem looks familiar, it should. We did this problem previously without using the quotient rule. Now we want to go and use the quotient rule. But let's first refresh our memory. Okay, so here's our problem when we did it previously, just to kind of quickly refresh our memory. There it is, x to the fourth. We rewrote that so that everything was a power of x, used our power rules, and we got one answer, which we said was okay, and we got a second answer by factoring out the x to the negative fourth along with the 1/8. Okay, so if you haven't seen this video, please go back and look for that. It's back in the previous section, 3.3, I believe it's called. So go back there and check that out. But the important thing is we've done this previously and we got this answer here. So I'm going to copy that answer into my problem. Here we are now back to our problem where we're going to do this with the quotient rule. But again, just for quick reference, there is the derivative from that other page when we did it without the quotient rule. So here we're going to begin by using our quotient rule, and again, kind of write out all of the detail here. This time I've left out the step where I say times the derivative, and I've actually gone ahead here and taken the derivative. So I have 8x to the cubed third, 8x to the third, times the derivative of the top. So the derivative of x to the fourth is 4x cubed. Derivative of 5x squared, that's my minus 10x. Derivative of 3 is 0, so it's gone. So bottom to top minus the top, that x to the fourth, minus 5x squared plus 3, times the derivative of 8x cubed, which is 24x squared. And then that's all over 8x cubed. Okay, so at this point, we want to continue with simplifying here using our quotient rule. So we're going to need to multiply through by the 8x cubed. Right, and we're going to need to multiply the 24x squared through here. And also don't forget about the negative. So as we begin to do that, 8x cubed times 4x cubed will be 32x to the sixth. Minus 8 times 10 would be 80x to the fourth. And then minus x to the fourth times 24x squared will be minus 24x to the sixth. The negative sign distributes to the 5, which makes that plus 120x to the fourth. All right, 24 and the 5 is 120. Negative sign makes that plus x to the fourth. And then 24 and 3 would be 72, but the minus sign makes that minus 72x squared. And then that's all going to be over. And it looks like I have a little typo when I wrote this originally. Lost my square on the 8x cubed there. And that's all going to be over that bottom function there, squared. So that would be 64x to the sixth. 64x to the sixth. And now we just want to go through and kind of finish this problem off by simplifying. So 32x to the sixth, we have that, which we can match up with the 24x to the sixth. Those are like terms. We have the 80x to the fourth and the 120x to the fourth, which are also like terms. And then the 72x squared doesn't have a like term. Okay, so 32x to the sixth minus 24x to the sixth would be 8x to the sixth. Minus, actually, which become plus because of the 120, plus 40x to the fourth. Minus 72x to the second, all over 64x to the sixth. Now there is a little bit more to do. Normally we don't worry too much in these problems about pulling out a numerical common factor, but as I look through there, I see, hey, 8 is going to go into all those things, which would cancel with the bottom. So yeah, here I do need to pull out that numerical common factor. There's also a variable common factor of x squared. So that needs to get factored out as well. So we just need to simplify here at this point. So we can do that by factoring out an 8x squared. That'll leave me with x to the fourth plus 5x squared minus 9. And that's all over 64x to the sixth. And then we can finish the problem off by canceling the 8 and the 64, reducing the x squared and the x to the sixth. And you see then that we do get the exact same answer that we had up above. Now you can judge for yourself whether this problem was better done with the product rule or better done with our other process. I think you could make a case really for either one. Some people might say, yeah, this is a lot of multiplication and like terms and that other stuff. And other people might say, yeah, but that other way I had to deal with all those negative exponents and factoring out negative exponents and stuff. And I didn't really like that. So you can kind of judge for yourself. Could probably make a case either way. But the important thing is both methods gave us the same answer.